Hi everyone, this is Benzenes and Halogens. Oh yeah, coming to you live from the closet. Let's start with benzene. So benzene you may recognize from your molecule project. It is a six-sided ring with double bonds every second carbon, and it's a very common molecule found in lots of different things. And there's a couple different ways we can draw it. The first picture there shows you its entirety, so it shows you all the bonding, and it's a little more complicated to draw that way, so we typically will abbreviate just like we do with all rings. So the corners of our shape will be the carbons and the hydrogens will be assumed. We can also draw it like this. And this is also a great way to draw it. It's quicker, which is nice, and it also actually shows you a little bit more realistically what's actually happening with the electrons in the double bond. So interestingly, although there are 3 double bonds that I show in the benzene, those double bonds can flip between the carbons. So the electrons are actually kind of always on the move. You can almost think of them circling around the ring, much like that second structure. This actually provides added stability for benzene. So benzene actually traditionally behaves like an alkane when it reacts versus an alkene or an alkyne. And we'll see that more when we get into reactions later on. So in terms of naming our benzene, the benzene is typically what we would call the parent shape, although not always. I will show you that in a moment. And just as always, if we have substituents hanging out on the benzene ring, we will just put them in front of the name benzene and organize them alphabetically. When we have a benzene ring, we don't have to indicate the double bonds in terms of their numbering or their location, because the name benzene is already indicating that it's a six-sided ring with double bonds every second pair. So that's not necessary. So we just, when we see this particular structure, we just call it benzene. When we're numbering the benzene, we're going to base it on substituents here, since it's symmetrical every way you look at it. So for instance, the example here, because there's only one corner that has a substituent on it, that would be the number 1 carbon. So I would simply call this one a methyl benzene. You could also, of course, add the 1 out in front of methyl, but typically the 1s are excluded. Let's try a drawing. So we want to draw the following: an ethyl 2,3-dimethylbenzene. So starting with our benzene, I'm going to do the kind with the circle in the middle. Again, they're interchangeable, so it doesn't matter. I like to put my number 1 at the top. However, you can decide whichever point you want as being the number 1, and then you can decide also whether you would like to go clockwise or counterclockwise. Those are choices you get to make. Because there's no number in front of ethyl, that is telling me that the ethyl, the 2-carbon chain, will go on the number 1 location wherever I decide that's going to be. Then I've got a 2,3-dimethyl, so I like to go clockwise. So I'm going to put my second methyl and then my first methyl, then my second methyl on the 2 and 3 locations here. Another feature to these benzene rings that sometimes crops up very occasionally is when we have just 2 substituents. And this is important because this naming that I'm going to show you does not apply to any other circumstance other than if you have 2. Basically, the rules that we use are what are called IUPAC rules. IUPAC stands for International Union of Practical and Applied Chemistry. And these are a set of rules established by a community of chemists all over the world. And it's a set of rules that establishes how do we name chemical compounds so that I can go and talk to somebody in another part of the world, and although we may not speak the same language, I might speak English, they might speak Arabic, but when it comes to chemistry, we all speak the same language. So it's a set of rules that we can all use and speak the same chemistry language. So IUPAC is traditionally what we use. However, before the IUPAC committee came together, we did have rules, and I like to call them old school rules, that were used and are still being phased out. So we do see them occasionally at this point still. So here's what we are dealing with when it comes to benzene and 2 substituents. IUPAC, we would use numbers. So if I had 2 substituents and they were in the 1-2 position on the benzene ring, meaning next door neighbors, they could be called an ortho arrangement or O arrangement. So what happens when we're naming is we can actually remove the 1 and 2 and replace it with an O, and it means 1 and 2. Again, I'll show you this with some examples. 1 and 3 is called the meta position. And again, it just means that I could, and typically you would use the numbers because that's the most common system, but if I gave you an M and then told you what substituents to put on, you would be putting them on the 1,3 position on your benzene ring. And finally, a 1,4 is called a para, and we would use the symbol P here. And again, we can replace the numbers with the P to indicate where the substituents are. Let's try it on for size. So for this particular one, I'm just going to look at the first and the last just to give us an example here. The first one, we have a 1, 2 positioning. So we might call this a 1, 2 dimethyl benzene. That would be the common name that we would use, the IUPAC name, and so traditionally I would expect that's what you would write as well. However, using the old school naming, we can take out the 1, 2 and replace it with O, because O means 1, 2. And again, dimethyl benzene. That part does not change. Let's pop over to the third example here, and I'm going to make one change here just so I can show you that the substituents don't have to be identical. So this last example, when I would name this one, I would put the number 1 down here at the bottom, just following that rule that if I could, I would give a larger substituent a lower number. So I'm just following that rule. I do that when I can. And so here I would have an ethyl for methyl benzene. And if I wanted to use my old school naming, all I'm going to do is I'm going to remove the numbers. The 1 is implied, and I've got a 4. And a 1,4 means a P. And then I'm just going to push the words together now. So P ethyl methyl benzene. And that's all there is to it. All right, this is a great time to pause the video, try these on your own, and then press play to see if you got them correct. So pause now, and I'm going to keep going. So we've got an O-ethylmethylbenzene. So starting with my benzene ring, I'm going to do the double bonded ones here like this, just to show you how interchangeable they are. This is an O. So this means a 1, 2 location for my 2 substituents. Again, I get to decide where the number 1 is. I like to put it at the top, but you can put it anywhere you like. That means my ethyl will go here, and my methyl will go here. In my second example, again, starting with my benzene, I'm going to do the circle variety here again, just to show you how interchangeable they are. And this time I have a 2-ethyl propylbenzene. There's no number in front of propyl, which means it's telling me that's the number 1. Again, I like my number 1 at the top. Propyl is a 3-carbon chain. And then my 2-ethyl, I like to go clockwise, but you can go counterclockwise. It's the same. And there you are. So the last little bit of dealing with benzene is sometimes benzene is not practical as the parent, and it has to be turned into a substituent. And when it's a substituent, it gets called phenyl. Now, listen, I would have called it benzyl myself, but I wasn't in charge. IUPAC started in 1919. I was not alive in 1919, so I didn't have a say. Nobody called me when they made this rule, I'm telling you right now. So, phenyl is the word we use if we want to call benzene a substituent as opposed to a parent. You might be thinking, why wouldn't benzene always be the parent? Well, let's have a look at an example. Let's say, for instance, I have my benzene ring, and let's draw a substituent here. This is looking pretty crazy. All right, so here is the problem. If I wanted to name the benzene as the parent, it would mean that this whole thing that I just drew is supposed to be named with one word. I don't know about you, but I don't have one word to describe what the heck is going on there. So when this happens, it's much easier to say, okay, this is way too complicated. Let's call this the parent. And now I can name substituents, including my benzene ring, and I'm just going to call it phenyl to say that it's a substituent and not the parent in this case. So that's how we work this out. And this is why this would happen sometimes, because there are situations where you just can't name it. The substituent is just not a good idea. It's better as a parent chain. So that's what we're seeing here. Let's do some examples. Actually, let's name this one. Why not? So the action looks like it's closer to the right-hand side. So I would number on this side 1, 2, 3, 4, 5, 6. And let's have a look in terms of putting it all together. Alphabetical order as per usual. So we have a 2, 2, 4, 4 tetramethyl, 3-phenyl, and then our we've got hexane. Obviously that would be better if it was all together, but it's not. I ran out of space. So there you have it. Let's try another one. I'm going to draw, you're going to name. You can pause after I draw and try it for yourself. That is an ugly looking benzene. All right, so this would be a great time to pause and then play to see if you get it correct. All right, I hope you're listening after you tried. In this case, we have, again, a situation where we would want the straight chain to be our parent chain. Let's see if you numbered this correctly. We should be numbering from the right here. And that's because if we can, we should be giving the bigger substituent the lowest number. And in this case, it's completely symmetrical left to right in terms of where my substituents fall. So this is a great opportunity to give the bigger substituent the lowest number when I can, and I can. So alphabetical order, this is going to be a 5-methyl, 2-phenyl, hexane. All right, let's finish things off with some halogens here. So the most common halogens we're going to see is chlorine, iodine, and bromine. And when I use them in a formula, I call them chloro, iodo, and bromo. And they just get put out in front with the rest of the substituents. And as always, we want to make sure everything is alphabetized. The most important piece when we're dealing with halogens is they are now the top dog. They're the bosses. And so when we are naming something that has substituents, multiple bonds, and halogens, halogens are the top position. Let's write it out here. So here's our new pecking order. Halogens are on the top. If I don't have halogens, then the second place boss, let's say the vice president, would be the multiple bonds, and then the lowly substituents are at the bottom of the food chain here. So that's the pecking order at this point when we are numbering. All right, I'm going to draw, you're going to name. After I do the drawing, it's a great opportunity to pause and then play to see if you got it correct. Here we go. Ooh. Almost fell for that. Oh, it's so confusing. All right, pause it now and then come back and see if you're correct. I'm going to keep going now, so I hope you paused. So finding the parent chain right through the center in this case. And then, again, we need to think about numbering. We want to number to get to the halogen the quickest. That means we're going to number from the right. So hopefully you numbered from the right as well. That's probably the most common mistake because I purposely put some big stuff down on the left to try to trick you here. But the halogen is the boss, so we have to number from the right. We have to get to the halogen as quickly as we can. Now we're putting things in alphabetical order. So we are going to have a 2-bromo, 4-ethyl, 5,5-dimethyl. I'm totally going to run out of space. Awesome. 6-phenyl. And we've got a 7-carbon chain, heptane, which which of course should be in there. Hopefully you didn't run out of space. So here are the homework questions that you're going to try about halogens and benzenes. Just a note about this first one. There are 2 boxes of homework questions. You're going to do the one called practice questions. Those are the ones that apply to you. Good luck and have fun.